Okay, so we're talking about operations with scientific notation today. This is part 1 of 2. In this video, we're going to add and subtract. In part 2 of 2, we're going to multiply and divide. By the end of this video, the lesson objective is this. I can perform operations with numbers expressed in scientific notation. In this video specifically, we're going to talk about addition and subtraction. Okay, so we're going to get right into it, but the first thing I want to remind you is that the number in front of the power of 10 in scientific notation is called a coefficient, and the number with the exponent is called the power of 10. Just a quick reminder, okay? All right, so there are steps to do this, and I want to just kind of look at adding and subtracting. Back when we were doing fractions, okay, and we were adding and subtracting, we had to have a common denominator, all right? So here's what I want to tell you about scientific notation. When you're adding and subtracting scientific notation, you need a common power of 10, all right? They have to have the same power of 10. And for our purposes of adding and subtracting, we're always going to create a number that goes to the highest power of 10 found in the problem. Okay, so let's look at the steps. Step number 1 says convert the numbers so that they have the same power of 10, and we're always going to go to the larger power. Second step is add or subtract the coefficient and keep that power of 10 the same, just like we did the common denominator in fractions. And then we're going to look at our final answer, either our sum or difference, and we're going to say, is it still in scientific notation correctly? All right, so let's try this problem. 9 times 10 to the third power plus 2.3 times 10 to the fourth power. So my first step says convert one of the numbers so that they have the same power of 10 and always use the larger one to go to. So our largest power of 10 is 10 to the fourth. So I'm actually going to convert this number right here. All right? I want it to be 10 to the fourth power. So I'm going to rewrite the problem. 10 to the fourth power. Okay? If I add one positive power, I know that I'm still swooping to the left. So I'm going to swoop this one more to the left. Okay? And so what I end up with is 9/10 times 10 to the fourth power plus 2 3/10 times 10 to the fourth power. Now I have the same power of 10. All right? I'm going to add or subtract the coefficients. And this is add, so I'm going to add this and this together. And when I do that, I get 3.2. And then I'm going to keep the power of 10. Okay? That's my second step. Now I want to look at this number and make sure that it's in scientific notation. Remember, scientific notation needs 3 things. The first thing it needs is a number between, or a coefficient between 1 and 10. Well, let's look. Is my coefficient between 1 and 10? Yes. Then it needs a multiplication sign, which it has, and then it needs a power of 10, which it does. So, 9 times 10 to the third plus 2 3/10 times 10 to the fourth. When I add those together, my answer is 3 2/10 times 10 to the fourth. All right, so subtracting is the exact same thing. Let's go through the steps. The first thing we want to do is we want to create our power of 10. Okay, 10 to the fourth is our largest, so I know the number I'm going to convert is this one right here. And since it's 10 to the second power now, I need to go 2 more decimal places to my left. Okay, so we're going to do that. Ready? 1, 2. And we add our 0 in. Now we're 10 to the fourth power. Okay? We're keeping our 8 times 10 to the fourth power. Now they have the same power of 10. That was our first step. Now we have to add or subtract. Well, it says subtract. So we're going to subtract our 2 coefficients. 8 take away 27 thousandths. Okay, and when we do that, we get 7/973 thousandths times 10 to the fourth power. All right, let's check and make sure that it's in scientific notation. This is between 1 and 10. 7.973 is between 1 and 10. It has a multiplication sign and a power of 10, so our answer is correct. I really think these are steps that you can follow, so I want you to pause the video right now, try this problem, notice that it's addition, okay? Run through each of the steps and see how you do. Okay, so step 1 says convert one of the numbers to the highest power of 10. Well, when I look, I see that 5 is the highest power of 10. Well, 5 take away 2 is 3, so I know I need to move my decimal point to the left 3 times. So let's do that. 1, 2, 3. Put a 0 there. So now we're going to rewrite it. This is 0.015 times 10 to the 5th power. Remember, I changed it. Plus 5.2 times 10 to the 5th power. Now they have the same power of 10, so I'm going to add the coefficients. And when I add those coefficients, I get 5.215 times 10 to the 5th power. Okay, so let's check and make sure that it's in scientific notation. 5.215 is between 1 and 10, the multiplication symbol, and a power of 10. Yes, it is in scientific notation. One last problem, and then we'll do a bunch in class. I want you to try this one, and I will tell you ahead of time it is absolutely okay to have negative scientific notation. Try it by yourself, pause it, try it, and come back and see how you did. Okay, so let's see how you did. All right, we're going to convert them both to the same power of 10. 4 is the highest power of 10, so we're going to convert this to 4, okay? It's one more positive, so we're going to swoop once, which makes this number 0.5 times 10 to the 4th power minus 8.9 times 10 to the 4th power. Now that they have a common power of 10, I can subtract them. Okay, so 0.5 minus 8.9 is negative 8.4 times 10 to the 4th power. Let's check and see if it's scientific notation. Negative between 1 and 10, yes. Okay, so negative 8.4 is between negative 1 and negative 10, so it's only got one digit in front of the decimal, times 10 to the 4th power. I do have multiplication, I do have a power of 10. So the answer is negative 8.4 times 10 to the 4th power. All right, I didn't do any negative exponents, but we will do that tomorrow. Just remember that when you're adding positive exponents to make them the same, you go to the left. When you're doing negative, you go to the right. All right, write down any questions you have. We'll get more practice with this next week.